Hi, welcome back, everybody, to another episode of the Apparatus Workshop. My name is Nick Wilbur, Fire Apparatus Emergency Equipment, here as always with Slauch. Today is, not necessarily a new topic, but a culmination of a lot of other podcasts, pulling information from there and some new information, and it's all about weight. I think it's such a big, important topic. We've talked about it probably just as much as mission of the vehicle, maybe if not more. But it's such a good topic that I feel like there's not enough knowledge out there. And there's so many different facets of speccing that touch on weight. And so we're trying to combine it into one ready to use package so that people can kind of understand it more. And this is not even just from a speccing committee. This is after the rig is in to before the rig leaves your fleet and, leaves the department, and everywhere in between, because everything that we do can affect the weight on the fire truck. So we can start with the speccing part of it, and then we'll kind of go into the after the fire truck comes in, and then kind of down the road, what we might do with it, and how that kind of from NFPA 1900 to NFPA 1910. So NFPA 1900, the speccing standard basically, and NFPA 1910 is the maintenance standard. So it kind of crosses both of those. I'm going to kick it over to Win, and kind of the first question here is when you're going and you're sitting down with somebody and you're speccing a fire truck, what do you think about, or what, I guess, facet for speccing do you see with weight? Like what is involved in weight in your thought process when you sit down to start this fire truck?
Yeah, I think that a lot of people kind of don't realize that that's probably one of the first things that you need to do. And it goes back to the whole, what's the mission of the vehicle, right? Because at the end of the day, we need to determine what it's going to do so we know what it's going to carry. And it's important that we know what it's going to carry so that we can pass those weight requirements on to the engineers, and then they build the truck around that. If not, they're going to take the numbers that NFPA provides in Chapter 9 of 1900, and they are going to utilize those numbers as your baseline, which in general is normally a good average, but there are times, especially on a rescue pumper or something like that, where you're going to increase above what the NFPA is going to use, or you're going to decrease. And both of those could have some pretty drastic, both ride quality and, at the end of the day, financial issues with what you're trying to do and build with that fire truck. So that's one of the first things we always talk about is, hey, what are you going to do with this? And then what are you going to carry? And then put the effort in and get out there and either go weigh it all or use the information that's available to determine those weights. And we don't need it to be exact, but if 2,500 is the number they're going to use and I come back at 4,500, well, that's a pretty big deal. And I need to make sure that information gets passed along, if it's 2,500 and it comes back at 28, that's not quite as concerning for me, right? It's a start. I know that we can probably start where we are, and then we'll run a weight requirement rating from the manufacturer, and then we'll finish that up. But again, if you're way off, or you don't tell them at all because you don't think about it, and it is your responsibility, then when that apparatus comes in and it's overweight, then you are very limited in the actions that you can take to correct that.
And I think, one of the biggest things I've learned, and this more recent is a relative term, but, from speccing the ladder truck at College Park, learned a lot of stuff, lessons learned from, the first time going through that whole entire speccing process. The weight requirement, or the weight starting point of the 2,500 pounds, 2,000, again, depending on what you're speccing, what NFPA is giving you, is like this, giant bar of weight. And they just kind of throw it on the rig and they kind of scatter it about, right? So it's not just what the weight is, right? Your combined total equipment could be equal to 2,500 pounds, and you could still end up with an overweight fire truck, because the location of that equipment is so important. If I take, and the manufacturer says, hey, I'm going to give you 2,500 pounds of equipment, and 2,200 of it is going to go on the rear axle. I'm only going to give you 300 pounds of weight in the front axle. And you go and you put a light tower, or let's say you already had that stuff, right? Because that's all coming with the fire truck. But you start putting paramedic equipment and drug bags and, bulletproof vests and all this stuff in the cab and up, forward of that rear axle or tandem rear axles. That's going to overload or load that truck differently than what the manufacturer was picturing. So again, it's not just what you have, where it's going to be on the vehicle. Same thing if you go underweight. If they're thinking you're going to put 2,000 pounds on the back end of this fire truck, of this engine or rescue engine, and you only put 1,000 pounds back there, anything from that rear axle rearward towards the back step of the fire truck, that is going to offload some weight on the front axle, right? It's going to take that weight and basically use it as like a little bit of a seesaw or a fulcrum, and it's going to lift some weight off that front axle, and it's not going, it's going to help her from being overloaded. So if you take 1,000 pounds off of that, now you're transferring some of that weight back onto the front axle, and now you could quickly become overloaded. Where again, the manufacturer is not thinking; they're thinking this is the weight, this is how it should be distributed, but the customer never told me, so I got to just guess, and hopefully my guess is right. And it's not just today weight. It's 10 years, 15, 20, or 30 years, depending on how long that thing stays in the fleet.
Right. And I think that's the key when obviously you want to give the manufacturer as much information as possible. But again, people just don't see through their head. Oh, where are you going to put this? Oh, we don't know yet. We'll figure that out when it comes in. That's a horrible time to figure that out. You need to know that stuff prior to going to pre-con. You need to know where your trays and shelves and all that stuff is going to go in order to make this work right, because you don't want to bring it back and then have the worst ride in the world because of things and decisions that you made or didn't do. So you're right. I mean, it isn't just the weight; it's where you're going to put it and thinking about that whole process all the way through.
And I think it's crazy, and we've talked about this before, and we hear people, oh, this fire truck rides, terribly, or can't keep it on the road, or pretty much you take any of the major problems or any communication that we get of a problem of a fire truck from somebody, and the first response back 95% of the time is, what are the weights of the fire truck? What's the weight on the front axle? What's the weight on the back axle? And then if A++, if you can get each individual tire or sets of tires weighed, individually to get just that, even more of a dialed in breakdown of where the weights are at. Right.
Right.
And that's so huge. We've seen underweight fire trucks to where they're less than 10% on the front axle of a loaded vehicle. So that means that 89%, almost 90% of the weight of the vehicle is on the rear axles or axle, and there's less than 10% on the front. So as much as we see overweight fire trucks, we've seen overweight in the rear, which then causes it to be underweight on the front. And that's something that NFPA 1900 addresses. It says that you need to be within the minimum and maximum ratings of the axles. And so, we see maximum ratings posted everywhere, but that's something that you have to dial in and ask the questions to and find out from the OEM, right? So if it's, your XYZ manufacturer, sole source, and they're building the entire thing, they should be able to tell you with that chassis what those axles minimum ratings are from the OEM, whatever your axle manufacturer is. If it's not, if you're taking a chassis and, let's say you're doing a tanker, you take a separate chassis and somebody else puts the vehicle together, I would go past that, the somebody else and go to the chassis manufacturer and figure out what my minimums and maximums are. Again, maximums are posted, but minimums are not. And that's something that you have to kind of dig into, but that is a huge piece of information to know and understand. If you're under those minimums, that means you're not getting traction, you're not getting steering, your ride quality is going to be terrible. All that stuff is going to be off because of those numbers.
Yeah. And I think part of that too, you say minimums and maximums, and the maximums are posted. Remember, we're talking about a whole system there, right? It's not just one component of that system. It's the axle, it's the spring package, it's the rims and the tires and all of that, right? So there is some play in there, which we found out through past jobs, or where you have the ability to make some changes if something's not reading properly, because again, it's that full axle system, not just one portion of it. So you could have a 22,000 pound front axle, that the axle itself is actually rated to 24, but because you put one less spring in it, or you change your tires or something, to where it's got to bring that whole package down. So again, it's important to have those conversations with what is what, especially when you find a problem too.
Right.
What ability do we have to address this problem?
Right. How expensive is this going to be to fix? Right. Am I replacing an axle, or am I just replacing one spring on a spring pack and we're good to go? Right. Again, like you said, weight is like just so involved. It goes from, like Wynn was saying, from the axle, you go out to the rim, the tire, the spring pack. Obviously, any shocks that are on there are rated for a certain weight. The tire pressure, the amount of pressure you keep in your tire, that is something that should be adjusted based on what your in-service weight of the fire truck is. A lot of the times the manufacturer will give you a tire pressure, but that's for the maximum load. And if you're not carrying that maximum load, that's not your actual correct tire pressure. And there's charts out there to figure out what that looks like. And then the last thing is braking, right? And in the big fire trucks, not a huge thing. They're built for the braking system and stuff, but that's a question to ask when we're starting to change, spring packs and things. You have to go back to the manufacturer, the person that put that fire truck together, and ask them and work with them if you're going to increase weight ratings to make sure you're not missing anything and it's engineered properly. But the braking system, when we look at those smaller vehicles, the 550s, the 5500s, whatever manufacturer of a smaller pickup truck style vehicle you want to go to, people look at the gross vehicle weight rating, the GVWR, of the front and the rear, and they're like, oh, I got 8 or 9,000 pounds in the front and 12 or 13,000 pounds in the back, and we got all this weight. But at the end of the day, the biggest limitation for those chassis is braking. So when you cannot overload the front, you could not overload the back. You could be within those actual weight ratings, but you could actually overload the entire gross vehicle weight rating. And because those are limited by what the braking system is capable of braking. So if you have a vehicle that's out there on a smaller chassis vehicle, and the younger kids or so, if your department are responding and it's going through brakes all the time, that's a problem. And again, first thing, this thing's going through brakes all the time, doesn't handle well. What's the weight? Again, goes back to that first question we would ask when we hear a problem. What is the in-service weight of that vehicle? And that out of all the vehicles we find overweight, that is a huge issue with those types of vehicles. Is they're putting a lot of stuff. There's a lot of hands in the pot between. You go out to a skid manufacturer, they slide a skid in there, everything looks okay. Then you come back to the firehouse 3 or 4 years later, you've added 6 chainsaws, you've added this, the cones, the traffic signs for the fire police. You start adding all this stuff on there, and it seems like you're within the weight. And at the end of the day, you're over that gross vehicle weight rating, and now the brakes cannot handle the weight on that vehicle. So it's a huge thing. So again, we talked about a lot of weight things now, but what about distribution? So we kind of dipped our toe into it, but how important is distribution for weight? Front to back, side to side.
Yeah, like you said, that distribution is key to making the vehicle ride properly, and more importantly, probably stop properly. The front to back NFPA just says that it has to be within the manufacturer's recommendation. So there's no number there. But again, ideally, we want to split this thing 50-50 if we can. Now, with water, with hose, that's not doable on most apparatus. Maybe a mid mount, we might be able to get close. And again, the axle ratings are, going to dictate that to some extent, right? But if we can get close, we can get 50% of the, not the full weight of the vehicle necessarily, but we can kind of split that. We're good. We're looking, if you're in the 35 to 28, 27% range on the front axle and the rest on the rear. I mean, I think that's kind of a good spot to be. You start to get over that, you might want to start looking about shifting some material or some equipment backwards. So again, that is dictated based on what the manufacturers say their products are capable of providing. Side to side is a little different. That's there's a number 7%. There can't be more than a 7% difference side to side in the weight of the two vehicles. I think that there could potentially, again, that's just the way that vehicle is going to twist and turn as you go around corners. If one's more heavy than the other, the tendency to roll that way or to affect your center of gravity could be, effective. And again, that's the importance of, putting the stuff in the right spots to help move that stuff around. If you're going to run like on a rescue pump or a vehicle extrication side and a pumper side, you can all see that the one side that's going to have cribbing, tools, all that stuff is definitely going to be heavier. So you may have to rethink about the way that you're going to distribute, like you said, distribute your equipment and how you're going to operate off that fire ground or on that fire ground. So, that's again really important. Now, airbags, the self-leveling that can occur can help. A little bit of that to some extent, but 7% is still that number that we want to be within on that side to side value.
Yeah, I think it's important. The overweight issue could be resolved by putting weight on the back end. Like you're under loading the back end, you don't have enough weight back there. Your distribution is too much on the front. You might need more weight on the back. And again, that could just be just being underloaded. The other thing is being underweight on the front. Your distribution is only, like we talked about before, 10% on the front. That's bad, right? We want to make sure we're adding some weight in there. And that could just be a misengineered fire truck, which if you are out there today and you think that the fire service manufacturers are batting 1,000, you're wrong, right? And there's mistakes that happen, and it could be the manufacturer, it could be the engineer, it could be the salesperson, and it could be the fire department. Or it could be, the specking, the people that are specking from the fire department, or just the fire department once it gets back into the firehouse. Everybody in that chain has a say and has their hand in keeping this vehicle within weight. And there's things all along the board that can change that. We've seen things like they order an engine, they don't have enough money for a light tower on the roof of the cab. So they order it, it comes in, gets delivered 2 years later, they get the money, they put the light tower on the front of the cab. Now the fire truck's overweight because they never told the manufacturer that they were going to put this 1,200 pound light tower on this fire truck. So now it's extra weight that they weren't accounting for. Fire truck's overloaded on the front axle. What's the way to cure that? Take the light tower off, right? So all this money and things that we were talking about, you've just wasted now because it's not going to be able to fit that. So I think that's huge. If you think you're going to do something in the future, you still have to tell the manufacturer that. You still got to tell them what you're going to do and where it's going to go. The hardest part about all of this weight is you have 3 to 4 years in some instances that you're waiting from when you sign contract to when you're getting this fire truck delivered into your firehouse. No one can tell what the technology is going to look like. And honestly, even if the lead time was only 12 months, you still have to look years and years into the future because you want to have some of those residuals in there. And so, NFPA doesn't give a lot of guidance on what buffers we should have or how much room you should have left on the axles when you weigh this thing and you put it in service. But what we look for is, we look to the ASE standard, which is the Automotive Service Engineer Standard, right? And that tells us that we want 5% residual on the axles. So especially when this fire truck comes in service brand new, the goal would be 5% residual on the axles. Now, for every vehicle, that's not always going to be possible, right? Wynn brought up the mid-mounted, aerial device earlier, specifically tower. That front axle gets a ton of weight on the front. So, if you have, 6 to 8 seats in the front, longer cab, it's a quint type device. Again, heavier aerial, longer ladder, you might be pushing it on that 5% residual on the front, and that's just going to be the design of the vehicle, and that's just that type of vehicle, right? But that is something that we should shoot for, is that 5%. So with seat weight, that's another thing. So talking about the cab, talking about front axles possibly being overloaded, when we look at how many firefighters we're going to put in the fire truck, and we've had this conversation before, if our staffing shows that we're averaging 3 people, 4 people per call, right, which we should be looking at, we've talked about that in the data podcast and plenty of other podcasts before, that piece of information there helps us discern how many seats to put in there. If we put 6 seats in there, that means that we have to account for the 250 pounds per seat times 6 seats all day, every day. It doesn't matter. I've heard conversations that, well, we only ride 4, so it's fine. Well, no, you've put the seats in there. You have to account for those seats being filled with people, because when, everything's hitting the fan and 6 people get on with all their gear because there's 6 seats, you need to be able to account for that weight in those people. And so when we start talking about 8 and 10 seats, that is a huge thing that we're accounting for. And this is something that we ran into in College Park a little bit, was, for us on the volunteer side, nights and weekends, we would ride 8 when we were lucky, when we had the fortunate, ability to have that level of staffing. During the daytime, during the week, when we had our career staff riding, they were down to 3. That's a huge, that's 5 people times 250 pounds worth of weight difference in the vehicle. So there was actually more complaints from the career staff on ride quality than there were from the volunteers, because they were not to the same capacity. So that flux in seating matters that much. And so that can go back into suspension and types of suspension to be able to handle that variance in weight. And there's a lot of obviously deep dives we can do from that. But that piece of information, again, is pretty important to know and understand. Where those seats fall also is important, right? The longer the cab is going to change where that load goes from. If it's the seats on the back wall versus right over that front axle versus the driver or the officer that's ahead of that front axle, that's going to change how that weight is distributed throughout the fire truck. So if you only put 4 seats in there and you decide that you're going to do 2 seats, or where the seats were, you're going to put compartments, that could change how that weight's going to be distributed, right? And so if it's closer to the rear axle than to the front, you would actually add more weight to the rear axle than you would just the front. So let's say at 250 pounds, 220 pounds would go to the front axle, but 30 pounds would be transferred to the rear axle. So it's not always just as easy as all these seats that I put in the cab always go over that front axle for the weight. There's actually calculations that are done, and NFPA has a guide on how to do those calculations. Wheelbase, length of vehicle, and then location of the weight all make, have a basically a 3-part calculation to where that weight's going to go in the vehicle. And then once you find that out, it's going to show you where that weight's going to end up, either the front or the rear axle. And it could be a plus or a minus. So as the driver, you're going to be a plus, not 250. You might be a plus 270, 275 on that front axle, and a minus 25 on the rear axle. Because again, you're doing the opposite, where you're offloading some of that weight from the rear. A lot of stuff to explain and kind of dive into without any visuals. But again, any questions you have, lean in on NFPA. They provide a lot of guidance there, or reach out, obviously. But there's a lot of guidance there on how to weigh the fire truck, what the weights look like in those NFPA standards, for a reason. It's important.
Yeah, and I think a lot of what you said there, when you go back into the specking of it, you're talking about potentially going, you're talking $15,000 to $20,000 in changes based on some things you said there, on just simple questions that you need to ask up front. And not even that, it's the ride quality and then the maintenance that comes from that over time. So if your standard is 8 people, but a majority of the time it's leaving with 3, like, we need to figure that out, because now, again, like you said, we're 250 pounds per seat. What does that do? Does that put me, in a 23,000 or a bigger front axle? Does it put me, do I need to get to fit those 8 people? Do I have to go with an 80-inch cab, which then extends my wheelbase and decreases my operational capability, as well as probably increases my brake size and all of that stuff all the way back to the truck, right? So just there's simple questions of how many people, it's nice. We all want to have 8 people going with us, but how many times does that really pan out? And what is the actual true average? And then let's build the truck to that and play the best of both worlds there. Obviously, we need to make, if you're in that combination fire department place, you need to make, the needed changes for that. If you're running 4 people, then maybe we do talk about dropping seats out. But whenever you drop seats out, people just see it as more space. So, I mean, if you drop a 250-pound seat out and put 280 pounds of equipment in there and don't tell anybody about it, you're not helping anybody.
It goes back to that article that was written by one of the EVR alum, and obviously my father. And, Mike, he wrote about the domino effect. And that's true with 100 different things that we can talk about. And in that article, was a very great article, was about water, right? And tank size. And people saw it as I need the extra water. That wasn't the point of the article. The point of the article was you make that decision to go 250 gallons of water, but what does it cost you? Right. And at the end of the day, I'm not in your first due. I'm not in your firehouse. I'm not responding to your calls. If you need the extra water, do it. Absolutely. Yeah. No one's there to stop you, right? And at the end of the day, when we go out there, we make recommendations, right? We just give you the information to make an informed decision. We're not trying to sway any decisions out there. I want to make that very clear. But you need to understand what the consequences are of the decision. There's no free lunch anywhere with a fire truck. You can build the shortest, most maneuverable fire truck in the world, but you're missing out on something, right? You might not have a 35 where you need it, right? You might not have a longer ladder. You might not have the water for where your hydrant system goes out once in a 20-year thing, right? Or you build it so that you can fit 8 or 9 or 10 people in the cab. You have all this stuff. Now you have a bigger motor, more gas, or more diesel fuel, which is going to be more in maintenance every year, more in fuel costs every year. It's going to be a higher budget, more repair, more ride quality issues because you're not riding those people all the time, greater wheelbase, greater cat. I mean, you just start going down the list to all the things like you said, which then you extend out and you add more weight. Bigger axle means probably less cramp angle. Less cramp angle means less turning radius, right? So now it's harder to drive. So if it's harder to drive every day of the week, but now only one day a month for drill night, I have the 8 people. Again, not my decision to make. If your department feels that strongly, go ahead, do it. But understand there is a negative effect. It's not always we're going to bring everybody and fit everybody all the time. Something else has to give on the fire truck.
Right. And it's I think that's just a mentality that you have to remember that you're not just changing one part. And it's the same thing we talked about the axles being a system. It truly is a system. And if you want to make one change, that potentially that piece touches 14 other things, right? And all those have to fit into the right place. So if you want to go from a independent front suspension to a standard straight axle, there are a whole bunch of adjustments and things, and even into the potential where now you have to adjust the way your body sits and has to have, cutouts for torsion bars and things like that. That's where that is, right? Nobody, you have to build a fire truck that works for you in your first due, but you also have to understand the overarching cost of that. It's not just one thing. There are 1,000 other hidden things, like you talked about, motors or this or that, and that have to go back into that as we think about it. And I think in that speccing process too, to kind of skipped over this a little bit, but when you're speccing axles, you need to have a conversation. What is this axle providing me with? What do I need to do down the road to ensure that this axle continues to, provide me the quality ride that I need? Is an independent suspension, does that have to be adjusted based on your final weight? So you get it, you put it all in service, it's a 24,000 front suspension, but you only end up with 22,800 pounds on it. Do I need to adjust that somehow? does that torsion bar need to be adjusted because of that ride, right? Does the airbags, do they need to be adjusted? The pressure in the airbags need to be adjusted based on, that ride or that, weight that we're going to put on the back of it. And then even a little bit farther is like, you go to your mechanics and say, hey, what do you think about an air ride suspension? Oh, we hate it. We have troubles with everything rusting out and this and that. Well, what do you mean you have troubles rusting out? Where are your drains for the air reservoirs, right? Is that a daily check that you drain your air reservoirs so that you're not getting rust and then the particles are not being pushed throughout the system to affect that? So again, you kind of have to look at that whole process there of what, based on the suspension I pick, what do I need to continue to do to continue to make sure that I still have that quality ride that I'm paying for. And we talked tires earlier too, right? Again, it goes all the way to the ground. Tires are meant to be run with a certain percentage of rubber on the road, and if you have it pumped up too much, then you're missing, the center of the tires hitting versus the outer edge. I'm sure TJ would yell at me if I got it wrong, and I probably did, but it doesn't matter. They're not riding the way they're supposed to ride, right? So, again, when that weight increases or decreases, then we need to make sure that the tire is within its right pressure range so that the proper amount of tire is hitting the road and carrying that weight all the way down to the ground.
I think this is a perfect opportunity. If you don't understand or know what we're talking about with tires or never heard that before, TJ, the tire guy, look him up. There's videos, YouTube, email, reach out. Most knowledgeable guy I've ever heard talk about tires, and could absolutely blow your mind. You think you even know anything about tires, you're absolutely wrong. And there's just such a wealth of information. And, he puts in a great perspective of, no one really cares about a tire until you're out there on the side of the road with a fire truck on its side, and they can go back and determine how long you were under pressurized, over pressurized with your tire, how well you took care of the tire, if it's in the right year or not, how long it was under pressurized, how long it was over pressurized, what weight was on it at the time of the amount of stuff that they could see and tell from the anatomy of a tire after an accident is insane. And, it doesn't matter that, if there's an issue with your tire, today's the day to take care of it, because they can see how long you've been neglecting your tires. And that's a huge DOT thing that goes past any fire department policy to just like federal law at that point. So again, tires, weight, all that stuff is important with the pressures and that. I think you got to check them out. There's not much more we can say and do it the proper justice that it needs without TJ obviously presenting it himself.
Yeah. All right, back on weights. You got on tangent there about tires.
We did get on tangent. I think it was a good tangent.
But like I said, it plays in because it's a system, right? It's a system. Yeah. You got to start from the ground up. And, along with that, and I think we can move past this a little bit, but there's requirements, inspection wise, daily inspections, yearly, annual, again, same word, but that you have to do in order to make sure that you're maintaining and properly outfitting your fire truck and really more importantly, operating a safe piece of equipment. As a driver, that's your responsibility to understand those weights, where they sit on a fire truck, and how the fire truck is going to react under those weights, right? A good wagon driver should be able to get in a wagon first thing in the morning and realize it doesn't have any water in it because, the crew prior didn't fill it up. But just because of the way it rides, right? Well, this thing's all over the place. Well, why is it all over the place? Well, it's all over the place because it's 8,000 pounds less, than it should be, right? So all of that plays into you being a safe apparatus operator. So, again, making sure that you know what your rules are. If you don't have the proper rules and requirements for a morning check, making sure that you start to implement that, because again, you're just covering yourself in that sense. But understanding what the weight is very important, and again, where that weight is and how it's distributed.
So and I think the safety part here, I mean, we've talked about a lot of cost and, we've touched on safety here or there, but I think the safety part can't be overlooked. If you get in an accident as the driver of the vehicle and you don't know what the weight is and you did not do a check of the day, you're liable. That's it. Someone's going to sue you and they're probably going to win, right? Obviously, it depends on locality and state. There's a lot of other things there. It's not just as black and white, as simple as that, but you are opening yourself up to be liable for the accident. And that can include being sued for wrongful death and, even up to criminal charges, right? They don't care that you're a firefighter once someone gets injured or killed. Now, all that stuff goes out the window. All the good that you did is gone. You could have 30 years of being the greatest driver in the world. And if you don't know your vehicle, you haven't done the proper inspections, that all goes out the window. And it's you. It's not the department. It's not. I ask this in every class that I teach, whether it's for truck company operations or EVOC or we're doing spec'ing classes, anything else. If who's responsible to know and understand the weight of the vehicle? And the department, the spec'ing committee, all those, absolutely. And you are the person at the end of the day. And so I think that's huge. The gross vehicle weight rating that's placarded on the placard within the view of the driver as required by NFPA is the maximum allowed weight the vehicle can weigh within the actual ratings. That's not saying how much the vehicle weighs. The only way you find that out is to weigh it. And so there's other things that play into weight. So we talk about step height. We've brought that up before with how your steps are going to be laid out and how you get in and out of the fire truck. Step height, ride height, all that stuff has to do with weight, right? If you let all the water out of an engine or a tanker, you're going to see it kind of rise up depending on the type of suspension and what's going on. So that's going to change your step height. So if you're not loading the fire truck to what you told the manufacturer, you're underloading it. You could actually have a higher step height than what you're supposed to be designed to have. If you overload it, it could be lower down, right? And you could be ripping steps or ripping things off and have a lower angle of approach or departure. And then again, from side to side, we've had somebody that had a separate water tank that was up and above over a set of compartments on one side of the fire truck, and it exceeded that 7% variance. And that was designed, built, and shipped from a manufacturer like that. So we need to understand that. One way that we can understand the weight, and especially with water, and check to make sure that our tank holds the right amount of water is to weigh the fire truck at final inspection with everything empty. Then we fill up the fire truck with water, we weigh it again, and then we empty the water again, right? Then we're going to get, there's 3 different weights. We should have an empty weight, a full weight, and then an empty after we've filled it up with water weight. If the first and the third weights of empty don't equal up, what's the problem there? Well, that means that there's water left in that tank that shouldn't be there, right? So if I got 1,000-gallon water tank, I fill it up, empty it, fill it up, and there's still, let's say, 1,000 pounds left, that means that there's 1,000 pounds of water weight still on that vehicle that didn't leave. So there's an issue with the tank, the way it's designed, the sump, wherever it's located at. And those are huge things that we want to test out, because that 1,000 pounds of water is going to be sitting in that fire truck for the entire lifespan of the fire truck. And so that's something that we've paid for, 1,000-gallon engine, and now we're really only getting a 780-gallon engine because those other gallons of water don't actually leave that tank. And so that's something we want to make sure we understand and fix before we leave that factory.
Yeah, I think you said something in there too about the plate with all the information on it. Is that those are max weights, right? And they're max weights based on that entire system, right? So if you do something to change that, then that plate needs to be adjusted as well. But it's also really important to pay attention to that plate, because again, if you it has the tires listed on it. If you don't put the right size tires back on it, then that can affect your weight rating, right? If you put tires that don't hold the weight that you're carrying on it, well then, you got to take stuff off, right? Same thing. If you put a heavier tire on it, you just have to understand the implications of what that means, and maybe it'll affect your ride or things like that. But you need to make sure that your drivers understand that and make those adjustments as well. as well. Those are just the maxes, not the minimums there. So
Yeah, and like you said, when you go get a tire replaced, you need to make sure that the tire coming on is the right age, right? Make sure it's within a couple months. Get documentation the tire was replaced and hold on to it. And you also have to make sure it's the right tire because absolutely we've gone and done fleet evaluations where they had wrong tires on there because it got sent out and the mechanic took care of it, or an outside vendor was dealing with the tires. They come and drop it off with the keys in it. They start it up and they're going down the road again. And like, oh yeah, we had tires changed 2 years ago. And for the last 2 years, they were smaller tires with less rate rating and actually put the vehicle overweight.
yep.
And again, that's just a huge thing that so many things to pay attention to. And that doesn't have to be a daily check where you're checking the tires. That should be a monthly check, or at least when it comes back from service. What was done to the vehicle? And then you have to spot check everything they did to make sure that they're doing it appropriately and it's being replaced with like parts and they're not downgrading any part of the vehicle. And any part of the performance, right? Like it should operate the same or better than it did before.
Yeah. I had that happen up the street here at home. I went in the firehouse one day and put new tires on it. They got all of them but the last one on. And I'm sitting there staring at it, and I'm like, that's not the right tire. So they had to take them all back off because what happened was that the guy at the shop loaded the wrong tires on the truck and nobody checked them. So, again, when you get that stuff done, it's your responsibility to make sure that the work was done properly. Again, to make sure that it maintains it stays within the weight of the apparatus for the entire time that you're responsible for it.
Well, my question to you is, at what point did you realize he was putting the wrong tires on? And then when did you tell him? Did you realize like tire 2 that it was the wrong tire and wait till you got to the rest of the tires? That's messed up, man.
No, but I did probably drink a pot of coffee before, because I walked in and walked past and then didn't probably until I was walking out. And then I was like, yeah, I don't think those are.
You finally clicked. All right. So we have talked a bunch about weight, and we've covered a lot of material. NFPA 1900 gives you guidance on what the weight should look like when you get the fire truck in. Again, don't rely on the manufacturer to do the calculations appropriately, right? We want to go out there, we want to weigh it before we get it to leave the factory, right? So when we're doing our final inspection, it should go over a scale. And it should be generally what they were looking for in weights, right? With the chassis and components and everything else, it should be within weight. We want to fill it up with water, right? If it has any water capacity on there, we want to weigh it again. Then we want to empty the water, and then we want to weigh it again, right? Making sure we're checking that tank capacity. Other things, when we weigh it, has to be topped off with all the fluids. So if it has a fuel tank full of fuel, oil, full of oil, full of all the fluids that it's supposed to have on there, and we're going to weigh it empty, right? So no people inside whatsoever, no equipment, anything, or no like gear or firefighting gear when we're weighing this fire truck. And so that way, when we go in there, we look at how many seats there are. And on a brand new fire truck, it's going to be 250 pounds per seat. And that's going to be our calculation. So if there's 6 seats, 6 times 250, and that gets added on to the vehicle weight. Again, there's a guide in NFPA 1900 that shows you where that seat is in relation to the rest of the fire truck based on wheelbase and length, and how much weight you should put on the front and rear axle based on that, right? So again, follow all that stuff, do the weight calculations. Again, it's work, it's kind of mindless work, but it is the most important work that you can do. Then, before you pay for the fire truck, before you accept delivery, right? Because we can set those terms. Before we do anything and say that this fire truck is ours, we want to put all of our equipment on it, and we want to get an in-service weight with everything that we told them we were going to put on it, where it's going to go, all the people, everything. We want all the stuff on there, and we want to weigh the fire truck again. Again, no people in the cab because we can add that weight in our calculation, but all of the equipment that will be on that vehicle. And if it is 1 ounce overweight, if it is close to being overweight, and you wanted a residual, you need to tell them and you need to fix it and have them fix it, right? You should not pay for an overweight fire truck. It is 2025 now at this point. There should not be a fire department accepting a fire truck from a manufacturer that is built, designed to be overweight. And we're at the point now where there's AI and all these computer programs and things like that, and we can't calculate or engineer a fire truck appropriately. And again, that's not one specific, it's happened across the board. And our trust factor, as far as just being like, you're a fire truck manufacturer, we're heroes, we're going to do everything appropriate and right, all that stuff is gone. We need to make sure that we're doing the right thing when we accept that fire truck. At the price it is now, that could be upwards of a $2 million mistake. That when we come in there as experts from the outside and we do an evaluation and we find it's overweight, that's on you to fix at that point, right? And like we talked about, it could be as easy as just put another spring in a spring pack, or it could be as difficult as you're taking 3 or 4 seats out of a cab, half the equipment you said that you wanted to carry on it ain't going to be carried anymore, and the entire mission of the vehicle is out the window. Or worse, it's going to be $30, $40, $50, $60,000 to get a new axle and suspension put on there to rectify this overweight problem. So that's that new fire truck thing. And then, weighing and understanding that. NFPA 1910, now we go to that yearly maintenance and what we should be doing to a fire truck to kind of keep up on it and be responsible with it. NFPA 1910 says every year we should weigh the fire truck. And why should we weigh the fire truck every year? Because we're hoarders. We like to keep things even though we shouldn't. Right? If you look at any firehouse across the country, I would say any, right? There's some good ones out there. I would say 80%. All the storage areas are filled. There's stuff everywhere, and we don't like to throw anything out because we might need to use it one day, right? And so with that mindset, we do that same thing with a fire truck. We get a new tool in. We don't take the old tool off. Sometimes we keep it on there. Hey, we spec this fire truck for 1,000 feet of 4-inch. Well, we're sitting there doing a drill or we run a call and we use 900 feet of 4-inch, and now we're worried that we might not get to the house the next time. That next house might be 100 feet farther away, and we're going to run out of hose. So instead of 1,000 feet of 4-inch, we're going to put 1,400 feet of 4-inch on there just in case, because maybe one time back in the 80s, we ran a house that needed 1,400 feet of 4-inch. So now that's our standard, even though we only told the manufacturer 1,000. Now we're 4 sections of hose over. No one's going to know unless we're weighing that fire truck every year. And again, that's just part of the maintenance that we're supposed to do. When this thing goes out for preventative maintenance, when you do your yearly inspection and you look that vehicle over, you should be getting a weight every single year. And then again, it goes back to now I have my weight from the factory when it was not loaded. I have my weight loaded with equipment and bracketry and stuff. Now when I go to spec a new fire truck, well, bam, we're done. We have a weight now that we can work from and give a manufacturer of what our tool and equipment will look like. And then again, that's to me the B standard, right? That is where you should be at to go spec a fire truck. The A standard, the A++, every single compartment on the fire truck, you should have what equipment's going to go in there and the weight for each compartment. That to me is the exact proper way to spec the fire truck to be like the best. Is it always possible? No, we understand it's not, but that is why it's the A or A+ standard there, because that's how important that is. Your fire truck will ride better. You can actually understand the vehicle stability better. They could do better engineering for it because the more information you give them, the better they can make that fire truck. There's no guesswork then at that point. You're telling them what you're going to do with that fire truck.
Yeah, I mean that at the end of the day, like you said, is an A+ method right there. It's but the second one is to provide them with a weight using either the FEMA cube calculator or your own weights and measurements. You can get pretty close, right? Let's get close. We don't need to be 100%, but let's get close. And that'll, we can dial that in as we go. If you're not 100% there with shelving and things like that, you can get it eventually. But we need to get close to start building this fire truck to ensure that has a proper chassis components and things like that underneath of it, and to make it safe, as we get down the road here. Again,
the NFPA is if you don't say anything to them. If you want to carry more weight than the NFPA says, you can do that all day long. You just got to let them know and tell them
right.
What the weight you're going to carry is. Again, better engineering. They're going to be able to provide a better product if they're able to do that. We have departments around us that are major departments, and they're like, oh, we're increasing the front suspension. It rides like crap. But what's the front axle rating. And they'll tell us, 22.5, whatever. Okay, cool. What's the weight on the front axle? Oh, I don't know. How are you changing an axle when you don't even know what you're carrying on that axle? Like today, right now, you're fixing a problem that you don't even know actually what the problem is. It could be that you don't have enough weight on the axle.
On the front axle, right? It might all be on the back axle.
Right. And you could be actually have a bigger axle than you need right now. And now you're actually going to make it bigger than it was before. Like, again, that stuff to me, the most of the problems that we talk to people about, the first thing is weighing. So if you're doing it every year, that's by far exactly what needs to be done. And again, where we're at as a fire service in total right now, I say the B standard is just to have the weight of the equipment and stuff, like just generally. That to me should be like the C or D standard. But where we're at as a fire service, we're just not there yet. That we could even get to that A plus to be the level standard. Right. So and that's okay. That happens. There's so much stuff on a fire truck speccing it to know and understand. And again, a lot of times it works out okay, and people just deal with the issues, and they'll just make fun of a manufacturer, switch manufacturers because there's a problem, not understanding actually what the problem is. Like all that stuff happens, and that's the reality of the fire service. Hopefully, if nothing else, listening to this podcast, you've picked up the importance of weight, how to weigh it, what that looks like, and like if you can even get to dialing it in to the point where it's in every compartment with your weights, like you're going to appreciate it when that fire truck comes in. You put it in service and you take that first call. You even just do driver training, go down the road, and you're like, wow, this feels good, right? You can save money on suspension now because you don't need this high independent suspension stuff. If you just tell them where the weights are at, you could actually have the cheapest suspension out there and probably still ride pretty good. So, yeah, I think we've we've beat that dead horse, which is good. I think it's that important that we can spend an entire episode on it. And I'm sure we will think of something, and tonight when we're laying our heads down to bed, we're like, we should have said that too, because there's just that much to cover. I think.
I mean, for sure. And there's always more that comes up, but the key, I think, at the end of the day is understand the weights from when you first conceive and discuss the mission of the vehicle, is understand how that is going to carry all the way through until it's done. And if you do it properly, you're going to build a safe and reliable fire truck that you don't spend a bunch of extra money on, right? We're going to keep it fiscally responsible because we put the right products on it in the first place. The right suspension, the right tires, the right, everything else that we have to do. It's the right length. It fits everything because we took the time to decide up front what we're going to put on it, where we're going to put it, and what we're going to do with it. Which again just increases the reliability of that apparatus throughout its career.
Yeah, as a driver, know your weight, 100%. If you're getting behind, if you're touching the wheel of that fire truck and you're pushing that maxi brake in and hitting D as a drive, you have to know that weight of that fire truck, and you should be weighing it every year, at least an in-service weight. Again, the C, B standard, whatever you want to call it, is an in-service weight. When that thing is loaded with equipment, we know what that thing weighs at some point in the life of the vehicle. Understand that to make sure it's not overloaded, right? When you spec a fire truck with weight in mind and mission of the vehicle in mind and do it appropriately, you will save big time in fuel costs. You will save in maintenance downtime. Again, fire truck available to be in service, ready to go to serve the citizens, which is huge. Tire wear, right? If you have a side-to-side imbalance, you're going to wear tires quicker or have gouges in tires or issues with tires. You're going to have better turning radiuses because you'll be able to unlock some more potential depending on the suspension and the axles. If you can lower that axle down, you can actually unlock a 50-degree cramp angle if you dial in that weight and where the weight's distributed. Better ride quality, front, back, side to side, left to right, better braking, less maintenance on brakes. I mean, the positives of doing this right just far outweigh the negatives of the little. I want to say little because that's downplaying it. There is a lot of work to do here, but there is work to be done in it. The benefits are huge. So, buckle down, seek guidance, seek help. If you copy and paste the department next door's spec, you better have the same mission, same weight, everything else. If that's different, then we need to sit down at the table and figure out what we're doing differently and adjust the spec to be that, right? Just because the next door neighbor has a 24,000 pound front does not mean that we need a 24,000 pound front too. It could, but again, you got to ask those questions and understand that stuff.
Yep.
Awesome. Well, we've taken up enough of your time, listeners. Appreciate you guys tuning in today. Again, a lot of information to cover there. Do the research, understand the standard, and always reach out if you have any questions. Us, neighbors, people that are good at this, and keep stay hungry for that information. Again, appreciate tuning in. Tune in to Fire Apparatus Emergency Equipment for more. If you have any questions or suggestions of other podcasts, things you want to hear, or questions about any of the podcasts we've done before, my email address is Nick, N-I-C-K, Wilbur, W-I-L-B-U-R, at evr.solutions. Again, 24/7, 365, we're here. So reach out if you have any feedback. All right, stay safe.
Thank you.
Go ahead. Stay safe, and we'll see you on the next episode.